nodes are humming, systems gonna overload. We got clusters making magic in the line. Funkified computing.
Hello. Good day to everybody. My name's Ed Fullman. I'm Chief Solutions Delivery Officer at Veritas Automata, and along with me is
Fabrizio Sgura, the Chief Engineer at Veritas Automata. And I go with the stupid question. Can you hear me?
I can hear you. We can all hear you.
Okay.
So, yeah, this is Cluster Funk, and we get together at the same time every month to have this conversation and advance our thinking about Kubernetes and how it all aligns with the work that we do. This episode 9, is about Edge IoT and the application-aware infrastructure.
So exciting.
Yeah, this is something that we know a few things about from doing it. We work with some partners, specifically SUSE, where we use some of their technology for managing these kind of environments in the field, these kind of distributed environments. But we also work with a lot of other hyperscalers and other groups that our clients ride their Kubernetes clusters on, clusters that we help put together and manage. So just kicking us off here around, kind of what is the business problem we're trying to solve here is that it would be, and it is, I'm sure, really great to only have to worry about a cloud cluster and nothing else, and not have a world that doesn't require something on the edge. But that's just not the real world for most companies, for a lot of companies, maybe not all. So, our destination and what Fabrizio and I do was never the cloud or exclusively the cloud. That was just the development experience or the beginning of things when we got into some of the stuff we're doing. Edge is where, for a lot of companies and industries, it's where the revenue happens. It's where the kinetic things happen as well, involving stores and labs and devices and logistics and patient workflows. That's all happening in the real world, not just in some simulation. And putting clusters close to these real world actors is something that makes a ton of sense for a lot of companies, and it's something that we've spent a lot of time doing. The problem is, or the reality maybe, is that you're passing through the internet, which has one level of reliability, but then you're passing into networks that our clients have, which is another level of reliability. And that becomes the real world physics, the regulated environments that we have to work with if we want to put edge clusters out there and run things on-prem, on the customer's prem, in devices that they have in the field. So that's the business of what we're talking about today, with essentially Kubernetes escaping the data center and getting out into the edge.
We have to stop it escaping. We have to control it. Absolutely. So yeah, the edge computing is something that is fascinating, because you kidnapped me at the time of when we met with this kind of concepts. about the edge. So I was thinking edge computing is just a mini Kubernetes that I run at home. It's not. It's not mini cloud. It's not mini Kubernetes. Is a very, very important core part of the business logic for whoever, also for who is doing experiments. And it is survival computing because you don't have the hyperscaler thinking about you and your cluster. You have to manage something that generally is your own node or a cluster of 3 nodes. So it's apparently less complex and less complicated. But when a field unit prevents delivery and is not functional because the control plane is in another region, that's not when you have a scaling issue, but it's a design failure. So you have to focus on how you design your units out there. You mentioned SUSE as our partner and constant source of knowledge for edge computing because they invested a lot of time on SUSE Edge platform, and we use several similar solutions in our reality where the coordination patterns and the chain of custody for data we can actually defend and protect at the edge. Think about companies that are working with core logic at the edge, like it could be a supply chain delivery. You have trucks that are controlled by an edge device that can be an Intel NUC, an embedded computer, or also a Raspberry Pi. All of that will have latency and will be subject to other problems that edge you know a lot because when talking with customers generally latency, uptime, and reality are constant point of failure of edge computing.
Yeah, I think, when you look at certain industries like just let's take retail for example. If there's a device involved, like an Intel NUC, living with some other components in a retail environment, or hosting them on that device with a cluster, that device needs to work, right? Or else payments don't happen. You don't make any money. You can't do anything to your inventory, like sell something. And, they can't wait on a VPN either, right? So everything's great until it's not. And then when it isn't good anymore, when there's a problem, that's where, you have to have made the investment in being able to ensure that you're going to come back up quickly, which Kubernetes orchestrating that is a good place to be. In life sciences, you could get into sample integrity. If there was a device with a cluster on it that was managing like sample containers and container systems, you've got to be able to keep that running with audit trails and be able to prove it later in some kind of chain of custody set of requirements. So the edge is about business continuity. When the WAN dies, business can't die with it. It needs to survive in some form, even if the internet goes down or there's some intermediate loss that is client specific.
Yeah, absolutely. And when we think about running clusters, we always think about engineers that are behind that. But in the case of a CEO or someone that is really managing the business flows of a company, those outages like network or problems when wide area network dies or similar are not really understood deeply. So it's not playing at the edge or at home with Kubernetes, but this intermittent connectivity, limited computing capacity, limited operations because you have to run your own Kubernetes, those kind of things are just understood really and in deep by technical people. And here we are to talk about technical people, but also about who has to understand why something not working is affecting the service level agreement or whatever. And the edge is the perfect use case where you have incidents coming out from questions like, why that's not working? What is happening? It's just a computer. You just have to run the software on top of that. But think about storage. Also, the stupid thing that is the clock drift. Sometimes you have the NTP servers that are not synchronizing, and that is creating a lot of problems with other resources that are connecting to the internet, including synchronization. It should be something that we solve, but these old problems, I see them daily in many cases, not because engineers are bad in automation, but because there is an outage, like in example, the 4G or 5G network is not working, so the synchronization is not possible. The battery of the motherboard is still not perfect and not monitored because there is no metric that is telling you that the motherboard is having a problem with the CMOS battery. And all of those small exceptions make this world of edge computing very, very limited in terms of knowledge to engineering, and something like a pain or a concept that needs to go to why it is happening. And the lightweight Kubernetes that we run at the edge can be K3S. Generally, it's better because you have a control plane, but if you are very out of resources, you can also use the Mirantis K0S that is basically Kubernetes running without the control plane. It's a value proposition and a small footprint with same defaults to easily install and upgrade your Kubernetes distribution at the edge. It's already ready to go, basically. And if I have to enumerate the principles of how you design and maintain an edge computing K3S cluster, I would say that it requires very, very small amount of activities. If it has 10 steps for bootstrapping processes and 3 external dependencies, too fragile. You don't have to put manual intervention or something that is not really automated. For that reason, we go to the concept of the immutable operating system. It starts, it's ready to be used. Not too many imperative scripts or something that is requiring integrations and similar. Edge has to be kept very simple. We say in technology that you have to keep it boring because fewer moving parts and predictable upgrades are causing that boring part that is you don't know what to do, but it's better. Boring means predictable upgrades, deterministic recovery, and no surprises when you lose connectivity. That is a case like the one of the NTP. Local first services don't hardly depend on cloud for every transaction. So you have to think about the focus. Your business is running at the edge when there is no one temporarily helping or connecting. It should be able to run as a standalone device. And for that reason, when you think about your nodes at the edge, whatever platform you are using, you think about cattle. So they are eating the grass wherever they want. They are producing something, but they are sparse. And they are in a closet behind a mop bucket. So the risks there, yeah, I think it's the typical example. If you open the closet and the mop bucket could behave unexpectedly.
Yeah, the handle hits the wire shorts out, the end. Yeah, so I mean, I think that the key takeaway here is this is an ops model. And the reason it makes sense for you is because the time and the cost to recover beats some theoretical 5.9 uptime that you have decided you're going to deliver in an SLA. So if you can't minimize your time to recover and create an environment that has, like, let's say for example, a graceful diminishing in capability because things are happening around it in the environment. If you can't do these things, then there's a cost, right, for being down. There's a possible loss of trust, for example, um, and not being up all the time. So, like a lot of people talk about in the data center business, everything's great until it isn't, and somebody calls, and at that moment, it's about the amount of effort you spent on, managing that edge and making that edge resilient that uh, makes people feel good that are working with you. Because when it's down, it's not good, and you're under a push then to get it back working. So, the real use case framing here is that uh, pharmacy pickup, lab drop boxes, cold chain monitoring, all the kind of things you kind of see in healthcare. Any kind of machinery that's running off of some kind of solution, um, including motors, doors, scanners, camera sensors, software. It's all accountable to these general business physics that we're talking about here, the business ops, right? And your customer doesn't care about the cluster health, right? They care that the system doesn't work, right? They can't get a door open on a processing system, or get a microscope to work properly.
Yeah, for that, I think that thinking about coordination, that is always the part that is the orchestrator of everything, the coordination in generally between people, between two engineers that are acting on top of a device, but also about the orchestration of services. So local orchestration for edge devices and for device control needs to be very well established as a deterministic and low latency pattern. Then you have queues. You remember the CQRS pattern, where you have query and queues for a model that is running commands. It's still a valid option because you can track the history of intents, and intents can be logged. Intent from the cloud is a call to a device in more technical language. So I cannot be sure that the device will be acting as expected. So I have an intent and I start with that command and I execute that on top of the device that will be executing it locally. So I have to reconcile later. I just need to run my intent. It's not a real transaction at that time. It's just an action that I want to know the results of. And cloud issues an intent. In example, open space 23 in that closet or locker or whatever, and that intent is logged locally, executed deterministically, and only then acknowledged upstream. So it's a constant interchange where if you don't have communication, there will be a coordination to implement something that is really understanding the business flow. And that can be done with tools like, an example, the private blockchain networks with chain code and smart contracts that are understanding these kind of things, and with idempotency. Idempotency. I always, this word is a big problem because it's idempotent. So it has to be everywhere. And retries will need to happen. But we remember that retries can become disasters because without this idempotency, a retry can become a second door unlocked. And it's anti an anti-pattern because it's not controlled. So cloud-only control plane for critical device actions, like we could have on our current cloud view, it's an anti-pattern. It's something you don't have to. And it's related to this isolation that we want to prevent. It's a constant question answer, command execution, and feedback, event emission. Just calling the API again without the transaction model, so the famous retry because I wait, it's not an option. You need to react to something. In Kubernetes, we have something that is called the crashing time, that is extending each time that is crashing. So you have a crash loopback that is always increasing. It's the only way to prevent the overusage of resources, but it should be designed better. So I should wait for something that is coming in an event. Like an example, should I retry to call that resource? Should I retry? And I try to call it. No, I just wait for the answer back that is, I'm back online, and I react. That is how you manage edge devices. There is no other way to solve this anti-patterns problem. And then you have the problem of the network, because initially you will work offline. It's like a challenge. You say, okay, let's say that this device is offline. What will happen? I don't have the cloud. I don't have to whom I relate or I have to communicate. Is this a bug to have the network down? No, it's another feature. So I need to be ready to think about working without the network. And network partitions are generally normal. And it's really something that it will require practical offline rules like local state machines for critical workloads. What we studied or we know from state machines is still very, very valid also in the era of AI, because everything is a state machine. Sometimes it's combined, but with the state machine, you can have persistent of events and actions. So something that is constantly evolutioning in a state that has to be persisted and that will result in a behavior. That persistence for events and action is also something that will require the reconciliation that we were talking about. So if there are two subjects interacting for an operation, or should we call it a transaction, we need to be sure that once the connectivity returns, there is no race condition, there is not a problem resynchronizing. It's just a normal condition. It's like you close the window, you don't see the outside. You open the window, what you see out there is what you know it should be, if it's a known scenario and landscape. So that's the point. There should be no unknown, and it's not something that when you are having some hopes that when we resync everything will work, then you are being optimistic and not deterministic, which is something very bad. And generally, it's the cause of failures. And this, Ed, I think that from the business perspective, is the most important problem that we have always seen when it's.
Yeah, I agree. I think the idea of an offline mode, for a lot of companies, it's an imperative. But even if you want to talk about it just in terms of money, it prevents revenue loss and safety incidents and other things. If you're in if you're building one of these new fusion reactors or whatever they are that are being prototyped, the last thing you want is not to be able to work in an offline mode. If the whole thing was on the cloud, you would be opening yourself up to a safety incident that would just be intolerable. But if you kind of approach everything with that level of seriousness, you're in a place where your edge device fails gracefully, and in a case where you have something important like a cold chain that you're monitoring, failing has a limit, right? You stop failing. You have enough offline capability to like keep it going, keep it alive for as long as possible. Um, if it fails not gracefully, instead of looking like a genius, somebody's thinking about how they can replace you. So this is kind of a key reason to do the edge, to kind of focus on building edge capabilities, and it's the importance of what you're trying to accomplish. So I think the next kind of stop here in our discussion is really application aware infrastructure, where we don't treat apps like noise, right? We need to um, break free from the tradition, where we look at infrastructure as CPU, memory, uptime. Application aware infrastructure says what outcomes must never fail. And this is the same question you ask when you're building an AI agent, right? This is the kind of constraint that an AI agent designed to make a decision for you has got to be able to answer. What outcomes must never fail, and on the other side, what outcomes must always survive. So examples here are, as far as application aware, order created versus order dispensed. These are like totally different risk tiers, right? Another example would be sensor telemetry delayed versus a chain of custody that is broken. These are different severity classes altogether.
Yeah, I was thinking that when you said apps like noise, I was so focused on the infrastructure that I was for a moment forgetting that you build this kind of highways to run the applications. It's not just to create a Kubernetes cluster and say, oh, it's communicating with the cloud. Yeah, I finished my job. No, more complicated. So you need tactics. And in Kubernetes, we have the node affinity, an example, to establish where to run critical workloads. And that could also be multi-clustering. So you can distribute the effective workloads of applications. When you create this playground, I call it playground because it's playful, but it's really a solid base to run the applications. You will need to establish what is your priority. If the workflow is needing to do something with the data and the chain of custody, or if it's more important to have an event emission from a specific condition. That is something that is really case specific. And then you need health checks that are able to match real semantics. So, in case of the business flow, if we were talking about opening a door or a window, if that's an operation that requires monitoring, you will have to put instrumentation on top of that, like a health check. Is the window there? Is the door there? Is openable? Is everything functional? Generally, it will not alter the state of your environment. But if something is altered, then you need local processes that are checking every status and every state. And then you need policy driven rollouts. In example, the ability to come back if some new release is breaking things, not just when you do the progressive delivery, because you could use Canary, but if you are using a specific application like the blockchain, in example, and a ledger, it will not be an option to do a Canary. You will need an A/B deployment, blue green, so you replace completely what is running out there. And rolling back is still an option. The important thing is to design these workflows in a way that they can really fulfill this requirement of coming back to a solid state where you were. And for that reason, you need observability. There is a lot of investment in terms of time, money, and people effort to design an homogeneous observability solution. We have OpenTelemetry that is doing a lot of things for consolidating the way that we can observe metrics, tracing for the applications. So the exact step where something is happening, and the logs, something that we write for us, for the human, to understand a specific response. And the main point that I always said also when we were talking about monitoring, we have to use the data that we observe. It cannot just be ingest. Okay, I'm having the monitoring solution that is working because the data are coming to my monitoring cluster or whatever platform I'm using. I see the dashboards, everything is working. But if I don't look at it and if I don't use it to activate triggers that are reacting to specific conditions, I think it's just thinking about dispensing medication that is more critical than telemetry upload. So if your business flow is healthcare or whatever related to life science, the deliverable, it's more important than the telemetry. But by the telemetry, you can have what your scheduler need to know for succeeding in effectively delivering the matter of your application. Blockchain as chain of custody, Ed, we started to talk about that a lot of time ago.
Yeah.
And I think that, trust me, is not enough for
Yeah,
that.
not for some environments. We've been working with blockchain since probably 2018, so we're coming up on 10 years of it almost. And blockchain for a purpose that is private, a private blockchain, like Hyperledger Fabric or Bezos or any of those products that give you ability to at least have some of the blockchain being private. These are tools that that make the business work. From in a regulated environment, you're building software, but really it's kind of like the discussion about how long does it take to get everything running again, right? You're really building to provide the evidence when something goes wrong, so that you're not trying to create a story when something goes wrong. You're just showing someone the evidence. And that's what blockchain is capable of doing in a chain of custody environment. So it tells the story after your system says something goes wrong, right? Something's gone wrong. So it matters incredibly when you're doing life science work with samples, or you're working with people in a healthcare environment, or if you've got high value retail where you're you're making a transaction between two people, and the cost and the value is very, very high, or you have compliance heavy logistics. Any of these environments, after something goes wrong, if you can't tell the story with evidence that is at some level immutable or auditable from that perspective, that it can't be changed, then you're at a disadvantage. And in some environments, it could mean the end of a project or the end of a business, because the whole concept of and the whole reason that you built it kind of fell apart, and you need to be able to prove that what you did was correct, and the failure was something that you should be able to understand and tell a story around.
Yeah, absolutely. And we are talking about blockchain, so I will go just 1 minute to clarify that it's not crypto, because when we use that word, people are thinking, oh, I will get rich investing in Bitcoin. No, we are talking here about something that is a definition. When I was doing the certification for Hyperledger Fabric, I found a definition in the questions that is blockchain is a structured, sequential, set of connected data structures where each data structure contains a sequence of a transaction. And this is redundant. You have to think what is the meaning of all of this. But basically, it's the transaction flow. So it's not performance, because you will need to be ensuring that everything is agreed in a consortium of business entities. And that is where local actions on the edge device are captured as events, as something that is signed, hashed, and later anchored and shared. And this is the power of blockchain. Something that is happening out there cannot be effective if you don't have the consensus. And for that, you will say, if everything goes well, you will never look at the ledger of the blockchain itself, so where you save the data. It exists for the day that something will go wrong, and you can check the information. Otherwise, if you are delivering something and it's delivered, why you should look at if it is being delivered? The event is already emitted, so it's closed. You don't see the real data that is transiting in the blockchain constantly like a database. That is a big mistake, using blockchain as a database. Transactional operations keep moving. And that is really something that will drive us to think about the design points, where we don't put every raw event on chain, but we put proofs and critical state transitions. Ledgers are for proofs, not for log aggregations. And the edge device is perfect for doing that specific activity that will get part of a consensus. Offline capable event capture and later reconciliation anchoring. This is what you want to do. Clear separation between the operational database for speed and the ledger for integrity. So you store data, but you eventually consult them in a spool set of event store, and you keep using the blockchain quite invisibly. It's your power for being consistent and immutable and secured. So I think we are on time at
Nearing the end here. So I think the one thing that we talk a lot about in the episodes we've done is the heroes in DevOps, and it's unfortunate when companies kind of plan it that way. Not that we've ever done that, but you end up with scenarios where you're relying on one person in DevOps to get things up on their feet again and running, or a very few number of people that have the skill and the experience to kind of pull that off. So an edge that doesn't require heroics is always the kind of goal that we have. So, you should be in a place with your edge platform. You should design it so you can feel it's a boring environment. It's something that you can count on, even when Amazon goes down completely and we lose it for X amount of hours. The ability to keep going and then react, thoughtfully, is something that will make everybody feel much better about, why they're paying us, or why you're paying your team to do what they do. So the real win here is consistent operations across hundreds or thousands of locations, which would mean probably billions of transactions. That's really the win, right? The T's is that fleet management, drift control, and everything else here. That's the next part of this discussion in the next episode that we'll do together. But I think that the opportunity here is to actually create an edge that could be built boring, could be consistent. What do you think?
For our use case, I think that today we were focusing on the fact that edge is where reality happens, wherever. Also, if you have applications running on the cloud that are mobile or whatever, other people interacting with those applications are at the edge. And edge systems should always recover by design, not by intervention. K3S is fantastic for lightweight runtime. The local first coordination, because, like you mentioned, the cloud could fail or whatever bare metal you have could fail. The local, that is where business is running, really needs to be valid, running, and deterministic. And I need that reconciliation explicitly designed for ensuring that whenever we have some outage and we go back working, we are ready to be fulfilling the requirements of restarting the synchronization that we need. And finally, the chain of custody, that is a word that we really like because that is for proof, not vibes, and the verifiable proof is what at the edge is really the thing that you have to ensure. We could talk about air-gapped environment, Ed, but there is no time. There are cases where the edge is acting completely disconnected from the outside, and they are probably the power plants, nuclear plants, and whatever entities that are running for us a lot of activities that we don't see, but without those activities, we will not function as we do as the mankind.
Well, that's our show for today. Thank you for joining. We're here every time this month, so each month. So please follow us and join us again for the next Cluster Funk episode. Thank you very much.